What is meant by progressions? Observe the following sequences. In this infinite sequence, each term is one more than the preceding term. In this finite sequence, each term is three more than the preceding term. In this infinite sequence, each term is obtained by adding 5 to one preceding term. This is an infinite sequence of alternating zeros and ones. In this infinite sequence, each term is obtained by adding 0 to one preceding term. In this infinite sequence, each term is obtained by multiplying it by 2 to the preceding term. If you observe the above sequences, there is a fixed relationship between any two consecutive terms except sequence of alternating zeros and ones. Such sequences are called progressions. Thus, we define a progression as a special type of sequence in which the relationship between any two consecutive terms is the same. See these sequences. Now, do you get any relationship between any two consecutive terms? For the first sequence, 2 plus 2 is equal to 4. 4 plus 2 is equal to 6. 6 plus 2 is equal to 8. After knowing the first term, we are getting each consecutive term by adding a fixed number to the previous term. For the second sequence, 8 minus 5 is equal to 3. 11 minus 8 is equal to 3. 14 minus 11 is equal to 3. The difference between any two consecutive terms is the same. Such a type of sequence is called as an arithmetic progression. The formal definition of an arithmetic progression is as follows. An arithmetic progression, or AP, is a sequence such that, given a first term, each term is obtained by adding a fixed number to the preceding term. This fixed number is called the common difference of that AP. It is denoted by D. The value of D may be positive, negative, or 0. General representation of an AP. If we have an AP T1, T2, T3, T4 and so on, then T1 is equal to A. T2 is equal to T1 plus D is equal to A plus D. T3 is equal to T2 plus D is equal to T1 plus 2D is equal to A plus 3 minus 1 into D. T4 is equal to T3 plus D is equal to T1 plus 3D is equal to A plus 4 minus 1 into D. Tn is equal to Tn minus 1 plus D is equal to T1 plus n minus 1 into D is equal to A plus n minus 1 into D. Thus, an AP can be expressed as A, A plus D, A plus 2D, A plus 3D, and so on. A is the first term, D is the common difference, and T1 is equal to A, T2 is equal to A plus D, T3 is equal to A plus 2D, T4 is equal to A plus 3D, and so on. Let us look at the examples. Write the next three terms of the AP whose first term is 11 and the common difference is 1.5. Solution. Here, A is equal to 11 and D is equal to 1.5. Hence, T1 is equal to 11. T2 is equal to T1 plus D, that is 11 plus 1.5 is equal to 12.5. T3 is equal to T2 plus D, that is 12.5 plus 1.5 is equal to 14. T4 is equal to T3 plus D, that is 14 plus 1.5 is equal to 15.5. Thus, the three terms of the AP are 12.5, 14, 15.5. Let us solve from exercise 1.2. Question 1. Which of the following list of numbers are arithmetic progressions? Number 1. 1, 3, 6, 10 and so on. Solution. T1 is equal to 1, T2 is equal to 3, T3 is equal to 6, T4 is equal to 10. T1 minus T2 is equal to 1 minus 3 is equal to minus 2. T2 minus T3 is equal to 3 minus 6 is equal to minus 3. T3 minus T4 is equal to 6 minus 10 is equal to minus 4. This shows that the difference between any two consecutive terms is not constant. Hence, the given sequence is not an AP. Number 2. 3, 5, 7, 9, 11 and so on. Solution. T1 is equal to 3, T2 is equal to 5, T3 is equal to 7, T4 is equal to 9, T5 is equal to 11. T1 minus T2 is equal to 3 minus 5 is equal to minus 2. T2 minus T3 is equal to 5 minus 7 is equal to minus 2. T3 minus T4 is equal to 7 minus 9 is equal to minus 2. T4 minus T5 is equal to 9 minus 11 is equal to minus 2. This shows that the difference between any two consecutive terms is constant. Hence, the given sequence is an AP. Number 3. 1, 4, 7, 10 and so on. Solution. T1 is equal to 1, T2 is equal to 4, T3 is equal to 7, T4 is equal to 10. T1 minus T2 is equal to 1 minus 4 is equal to minus 3. T2 minus T3 is equal to 4 minus 7 is equal to minus 3. T3 minus T4 is equal to 7 minus 10 is equal to minus 3. This shows that the difference between any two consecutive terms is constant. Hence, the given sequence is an AP. Question 2. Write the first 5 terms of the following arithmetic progressions where the common difference D and the first term A are given. Number 1. A is equal to 2, D is equal to 2.5. Solution. T1 is equal to A is equal to 2. T2 is equal to T1 plus D is equal to 2 plus 2.5 is equal to 4.5. T3 is equal to T2 plus D is equal to 4.5 plus 2.5 is equal to 7. T4 is equal to T3 plus D is equal to 7 plus 2.5 is equal to 9.5. T5 is equal to T4 plus D is equal to 9.5 plus 2.5 is equal to 12. The first 5 terms of the arithmetic progression are 2, 4.5, 7, 9.5 and 12. Number 2. A is equal to 10, D is equal to minus 3. Solution. T1 is equal to A is equal to 10. T2 is equal to T1 plus D is equal to 10 minus 3 is equal to 7. T3 is equal to T2 plus D is equal to 7 minus 3 is equal to 4. T4 is equal to T3 plus D is equal to 4 minus 3 is equal to 1. T5 is equal to T4 plus D is equal to 1 minus 3 is equal to minus 2. The first 5 terms of the arithmetic progression are 10, 7, 4, 1, minus 2. Number 3. A is equal to 5, D is equal to 2. Solution. T1 is equal to A is equal to 5. T2 is equal to T1 plus D is equal to 5 plus 2 is equal to 7. T3 is equal to T2 plus D is equal to 7 plus 2 is equal to 9. T4 is equal to T3 plus D is equal to 9 plus 2 is equal to 11. T5 is equal to T4 plus D is equal to 11 plus 2 is equal to 13. The first 5 terms of the arithmetic progression are 5, 7, 9, 11, 13.